Okay, so we're going to finish up solving triangles, looking at what's called the law of cosines. And first thing is we want to remember, what the law of sines is used for, and then we'll write down those cases, and then we'll write down the cases we use this one for. Now, let's say we had a problem like that. Maybe we'll do that as our first problem. Yep, we will. Not right now, though. Why can't we use law of sines to do that? There's not a full row. So remember, when you do law of sines, you're setting up a problem like this, and it has 4 spots in it. You fill those 4 spots in by picking 2 rows of information. Whatever 2 rows you pick, you have to know 3 out of the 4 things. Well, if you pick the first 2 and you say, all right, let's try those, you're missing 2 things. You can only be missing 1. Right? Let's try another 2 rows. Let's try rows B and C. Well, if you pick B and C, you're still missing 2 things. And if you pick A and C, you're still missing 2 things. So there is no combination of rows you can pick that has 3 out of 4 things in it, because you do not have a full row. That's the problem. So that's where we use the law of cosines. This problem is an example of SAS. A side, an angle, and a side. Both SAS and SSS have to be solved with law of cosines. So on the left, it's just a different example of an SAS triangle. What makes it an SAS triangle is you know 2 sides, and you know the angle that's between the sides. That complicates it because you don't know a side and something opposite. Right? You know this side, but you don't know what's opposite. You know this side, but you don't know what's opposite. And you know this angle, but you don't know what's opposite. You don't have anything opposite. And it's the same thing with side, side, side. Okay, you know this side, but you don't have the opposite angle. With this side, you don't have the opposite angle. And with this side, you don't have the opposite angle. So that's another problem where you would not have a full row. So if you want to make a table for the test, you could put law of sines, and then put the 3 types yesterday we did. Then you could put law of cosines, and put these 2 types under it. So now there's 5 different types. With SAS, you never have to worry about 0, 1, or 2 solutions. This is completely normal. Nothing weird can happen with that kind of stuff. With side, 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 you can end up with 0 or 1. You cannot end up with 2. The only one you can end up with 2 is the one we learned yesterday. So how could you end up with 0 with side, side, side? Well, think about this. Let's say you had sides of like 1, 1, and 200. Could you draw a triangle if one side was 200 units long? Let's say that one's 200. And then the other 2 sides are 1 and 1. No. I mean, if that's 1, it's going to look like that. If that's 1, it's going to look like that. There's just no way those sides are ever going to meet. So what's the rule here? Okay, the rule for sides is that any 2 sides added together have to be bigger than the third. Okay? Any 2 sides added together have to be bigger than the third. So any 2 sides added up have to be greater than the third side. So if you check that here, 7 plus 10, yeah, that's bigger than 6. 10 plus 6, yeah, it's bigger than 7. And 7 plus 6 is bigger than 10. So those are realistic numbers. Could you make a triangle with sides 1, 4, and 5? No. Any two sides added together have to be bigger than the third. 4 plus 5 is 9. That's bigger than 1. That's fine. 1 plus 5 is 6, which is bigger than 4. But the problem is 1 plus 4 is 5. 5 isn't bigger than 5. You could not make a triangle with those measurements. Okay, so keep that in mind for side, side, side.
So if they don't, would it just be a no solution?
You'd have to write no solution. Yeah. So let's look at what the law of cosines is. So in the formula, we're going to use the same labels we're used to using. A, B, and C are going to be sides. Alpha, beta, and gamma, angles. And when I show you the first part of the law of cosines, I think you're going to recognize what it looks like. What does that look like? Pythagorean theorem. And if we were going to prove the law of cosines, the proof of the law comes from the Pythagorean theorem. Okay, we don't go through the proof, but it is based on the Pythagorean theorem. Now, it can't just be Pythagorean theorem, because we know Pythagorean theorem only works for what kind of triangles? Yeah, a right triangle. These aren't right triangles. So what happens is, it's like an adjustment on the end of the Pythagorean theorem, something we're going to subtract. And this adjustment makes the Pythagorean theorem work for any triangle, not just a right triangle. So it's really like the Pythagorean theorem adjusted. That's the law of cosines. And that is what you subtract. So let's kind of look at the pattern here without reading specific letters. You have one side squared. One side squared equals the sum of the other two squared minus twice the product of the other two times the cosine of the angle that's across from the letter you started with. That's the pattern all the time. So we can write the law of cosine starting with A, B, C, X, Y, Z, Q, R, whatever you want to use. You could write it 100 different ways, but it follows this pattern every time. Okay. So if I started with B squared, anybody think they know what would come immediately after? It's going to follow this same pattern. A squared plus C squared minus 2AC cosine what? Beta. There you go. All right. How about if we started it with A squared? B squared plus C squared minus 2BC cosine of the angle across from the letter you started with. Yep. So the point really is not to remember the exact letters, because if I give you a problem like this, let's say 3, 4, and 6, make sure that would actually work. Yep, that's fine. When you have 3, 4, and 6, they're not labeled. I don't know which side is A, B, or C. I mean, call them X, Y, and Z if you want. The formula is always one side squared equals the sum of the other two squared minus twice the product of the other two times the cosine of the angle. Now, let's look at what happens if you try to use this formula on a right triangle. It would work. But when you have a right triangle, what do we already know this angle would be? This would be a 90. If you tried to use it on a right triangle, that would be a 90. Now, look at what the cosine of 90 is. 0. What's 0 times anything? 0. So what would happen is if you try to use this on a triangle that already has a 90, this entire part becomes 0. And you're left with just the Pythagorean theorem. That's why when you use Pythagorean theorem on a right triangle, you never see this part, because it would always be 0. When you don't do it on a 90-degree angle, then this part will not be 0. And then it makes a difference. So that's the law of cosines. So I mentioned there's two different types: side angle side and side side side. We'll try one of each. Okay, so that's the first problem that I gave you. A is 2, B is 3, and gamma is 60 degrees. Okay, so what do you have to do first? Well, when you're solving a problem that doesn't have a full row, the first thing you should say, okay, this is law of cosines. Law of sines will not work. The second thing is, you always have to solve for the side you are missing. You can't do this yet, and you can't do this yet. Find the side that you're missing. That's the first thing. After that, you can do whatever you want, but you have to find that first. So what I want to do is write down the law of cosines that would allow me to use this piece of information, this one, and gamma. So I have A, I have B, and I have gamma. So let's go back and look at it. Which formula here? Well, they all have an A and B in it. So I guess the deciding factor is which one has gamma. The first. You've got the A, you've got the B, you've got the A, you've got the B, and you've got the gamma. You have everything on the right-hand side of the equal sign. You can fill it all in, and then find C. Okay. So what I want to do is write down that formula so I don't have to think of the formula and fill it in at the same time. Can someone remind me, what's the formula that we just decided to use?
B squared equals A squared plus B squared minus 2AB cosine.
Okay, now fill it all in. So this is to find C. Okay, let's go through it. And we can square some of them kind of as we go. What's A squared? That's 4. What's B squared? It's 9. Now I need 2 times A times B. Well, what's 2 times A? 4, right? 2 times A means 2 times 2. So A is 2. So 2 times 2 is 4 times B. What's 4 times 3? 12. So that's 2 times 2 times 3. 2 times 2 times 3. It's 12. Cosine. What am I filling in for gamma? 60. Okay. What can I do next on the left-hand side?
4 plus 9.
Yep, you do 4 plus 9, and that gives me 13. Okay, how about, can I do 13 minus 12? No, why not?
Order of operations.
Order of operations. You can't do subtraction until you finish multiplication. So you need to multiply 12 cosine 60 first. So let's do 12 cosine 60. That gives me 6. So what must the cosine of 60 have been? Yeah, it must have been 0.5. Because I got an answer of 6, and I multiplied 12 times something, and I got 6. So cosine 60 must have been 0.5. Okay, so now I can combine 13 minus 6, which is how much? 7. And what's my last step? To get c by itself. Take the square root. And in this case, we're going to round that off. And that's going to be our answer. Okay, so square root of 7 is about 2.646. Any questions on that? Now, what do you notice about our table? We do have a full row now. So, in theory, you could attempt to finish this with law of sines. But there's some situations that can come up if we do that. So my advice is going to be, if you start this with the law of cosines, just finish it the same way. I'm not going to get into what can happen if you do law of sines, but there is something that can happen. All right, so now let's finish this up with law of cosines. You know all three sides. Once you know all three sides, you can use any version of the formula you want. So let's do it to find alpha. Okay, before I even fill in any numbers, can someone just remind me, what's the version of the formula that has alpha in it?
30.
Yep, can you tell me what it is?
A squared equals b squared plus c squared minus 2ac cosine alpha.
Okay, and let's fill all that in. Okay, so a squared, go back up. What's a squared? 4. What's b squared? 9. And what's c squared? 7. A lot of people go back and they say, okay, well, I'll take 2.646 and square it. Why? You already have c squared right here. C squared is 7. If you take 2.646 and square it, you're probably going to get like 6.999 or something. So c squared is 7. Now, I do need a calculator. 2 times b times c. Well, let's start with 2 times b. What's 2 times b? 6 times c. So I need 6 times 2.646. 15.876. Okay. And now it should start to get smaller each step. Okay, that's like the biggest it's going to get. Okay. What could I do next in that equation?
9 plus 7.
Yeah, we can do the 9 plus 7, which is how much? 16. And the next step is exactly the same as what you would do in this equation. 4 equals 16 minus 15 times something you don't know. So whatever you do next here to start getting x by itself, you do the same thing up there. So what would you do next? Yeah.
The inverse of 15.87 cosine x? Or is it just cosine x?
Well, if you were solving this, what would be your next step to get x by itself?
Oh, isolate the variable.
Yep, we want to do that. There's going to be 2 steps left to do that. What would be your first one?
Subtract 16 from both sides.
Subtract 16 from both sides. You cannot do 16 minus 15. Those aren't like terms. Same thing here. That's 15 is being multiplied by something. You can't combine those because they're not like terms. So bring the 16 to the other side. That's gone. And what's 4 minus 16? So you get negative 12 equals negative 15.876 cosine alpha. Now the next step would be the same as the next step in this one. What would be your next step? In this equation, it would be the last step. In this one, it's going to be the second to last step. I like the divide,
Negative.
but divide by negative 15. Divide by negative 15.876. The number's gone, the negative's gone, and that negative is gone. Now, at this step, you can look at the left-hand side. If you don't have a bigger number in the bottom than what you do in the top, then you can just stop because something's wrong. We have a 12 in the top, we've got a 15 in the bottom is bigger. That's good. If the bottom isn't bigger, it's not going to work. And I told you earlier that this kind of problem always has a solution. We already got one solution, so why all of a sudden halfway through would we stop getting answers? That doesn't happen. Right? So bigger numbers in the bottom, that's good. Okay. So don't even divide that out. Just leave it, because the more times you round things off, the worse the answer is going to be. Okay, and what's my last thing? Take the inverse cosine. Okay. Inverse and regular cosine cancel each other out. And now type that in on the calculator. I'm never going to figure out what 12 divided by 15.876 is. I don't care what it is. I'm going to figure out the inverse cosine of it. Because the less rounding I do, the better. So just type it all in like that. 15.876. Okay, so we get 40 point, well, if we want to round that to 3 decimal places, it ends up rounding up to 40.900. The whole thing rounds up. 40.900. Okay, so that's that one. And now the third angle, well, that one's pretty easy. How can we get that one once we have those two? Yeah, so these add up to 100.9. 40 and 60 is 100 with the 0.9. And then subtract that from 180. Minus 100.9 gives me 79.100 if we want to keep that accuracy. Okay, and that's a law of cosines problem. Specifically, side angle side. Side angle side has a little bit of everything in it. The first time you did it, you solved for a side. The second time you did it, all this, you were solving for an angle. So you have to do both. When you have a problem like this, you're never going to be solving for the side. You're going to be solving for the angle every time. Okay, so remember what I told you. The only restriction on law of cosines is you find the side that's missing first. What side is missing? None. So you can do anything you want first. And the advantage of this kind of problem is you can do everything separate if you want to. You can find this one based on those three numbers, this one based on those three, and that one. You never have to use something you find here to find something else if you want to do it that way. If you want to do it that way, you're going to have to do law of cosines 3 times. But no matter what, you're going to have to at least do law of cosines a minimum how many times?
Once.
You gotta do it more than that. You gotta do it at least twice. Because then once you have these two, you could just subtract from 180. But the downside to that is if you add these and subtract from 180, what happens if you get one of these wrong? Then the other one's wrong automatically. So the safer way to do it is to do law of cosines 3 times, but that's going to take long. All right, let's do law of cosines. I want to use one we haven't used yet. We used the one with gamma and alpha. So let's do the one with beta. Okay. Can somebody remind me, what is the law of cosines that has beta in it? Yes?
E squared equals A squared plus C squared minus 2AC cosine B.
Can you just say that angle again?
Cosine B? Or is it beta, sorry.
Beta. So B squared, A squared, C squared, 2AC cosine beta. Perfect. And the nice thing about side, side, side is a lot of times they give you nice numbers, no decimals. So it makes it a little easier to do. Okay, what's B squared? A squared? And C squared? 36. Now we need 2 times A times C. All right, what's 2 times 4? 8 times 6. 48. Cosine beta. All right, now we do the same thing we did on the last problem, except there's no decimals. Tony, what can I do first on the right side?
Add 16 and 36.
Yep, and what's 16 and 36 going to give me?
It's going to give you 42. No, 52.
52. So yeah, 52 minus 48 cosine beta. All right. Ryan, what would be my next step?
You'd have to do the 48 cosine, right?
Well, that's a variable, so that would be like trying to do 48 times x. We don't know what x is, so we can't multiply. We have to subtract the 52 from both sides. Put the 52 on the other side. That's gone. And just do 9 minus 52. That's negative 43. Gavin, what would be my next step?
Would you get rid of the negatives?
Okay, we can cross the negatives out because we have a negative on each side, so that's fine. And then what would you do?
Divide.
By?
48 cosine.
We can't divide by a word.
Okay. Then,
Only divide by numbers and
43.
variables. So what did you say divide by?
43.
So, like, if you had this, what would you do next to get x by itself?
Oh, divide by 48.
Right. Divide by what's ever in front of the thing you're trying to get by itself. So in our case, the thing we want by itself is cosine. So we're going to divide by 48. Okay. And really, we're dividing by negative 48, but Gavin already canceled these negatives. If you hadn't, they would have canceled at this step right here. Okay. Don't worry about what 43 divided by 48 is. Just leave it. And now, how are we going to get beta? Inverse cosine. I didn't mention it this time, but the bigger number is in the bottom. That, again, always needs to happen. If it doesn't happen, you got all the way to this point, then it probably was a side problem that had no solution, and you should have checked the sides before you started the problem. All right, so inverse cosine of 43 over 48 gives me an angle of 26.384. Okay, so now we've got one angle. We would do law of cosines one more time to get whichever one you want, and then add them up and subtract from 180. But does anybody have a question on how you do law of cosines one more time? Just exactly what you repeated here, but all the numbers are going to switch around. But they'll be the same numbers, different spots. Any questions? Okay, so that's your side. You're doing the same thing twice, finding two angles. All right. So the last one we're going to look at is a word problem, but luckily I think we can find what they want us to find right away, and you don't have to find something else. So the idea is there's going to be a surveyor that's standing in one spot, and they're, like in this room, an example would be they're going to know the distance from where they're standing to the file cabinets, and they're going to know the distance from where they're standing to the calculators. And the question is going to be, what is the distance between the file cabinet and the calculators? Now, here, we could just measure it. That'd be easy. But there might be something in the way that's preventing the surveyor from measuring from there to there. Maybe there's, maybe there's a big building in between the two, or maybe there's like some kind of big pond or something. They're trying to get the distance from one side of the pond to the other, and they don't want to have to get a boat, put a tape measure, and then drive it across. They don't want to do that. So they just want to be able to figure out the distance between two points in front of them. So it says that. In this case, we're finding the distance between two houses. Angle ACB is going to be the angle where the surveyor is standing. So like in this room, would be if I drew a line to the file cabinets and to the calculators, what's the angle? If those two lines come right back to me. And that angle is going to be 70 degrees. Okay. And then the distance to one of the things I'm looking at is 50 feet, and the distance to the other thing I'm looking at is 70 feet. What's the distance between the two? Now, again, you might just say, well, why doesn't the surveyor just go out and measure the distance directly between the two things? Sometimes you can't do that. Right? You might have a river, you might have a pond, you might have a building, or you might have dangerous creatures between the two houses. So, first thing we got going on is we got these giant crab things. I mean, they're as big as the house, so I don't know, I'm not going to go near those. The second thing we got is we got the poisonous tree frogs. So we don't we don't want to get bit by them or whatever they do. And the third thing, we got an Easter bunny. I mean, I don't know. He's not looking right to me, so I'd stay away from him. So there's things between the two houses that we can't measure it. And I didn't have a picture of a surveyor. I couldn't find them in the library for this program, but I could find a soldier from World War II. Okay, so we got our soldier. So pretend like he's a surveyor. So we're going to know that distance. We know that distance, and we want that distance. Okay, so let's read what it says. Angle ACB is how much? 70. That's right here. Okay, so we got that. And it says the distance from, let's see, A to where he's standing is 50 feet. And the distance from B to where he's standing is 70 feet. Distance from him to house A, and then from him to house B. Okay, how far apart are the two houses? Since we don't know how far apart they are right now, how could we represent it until we figure it out? Like we have to have something that represents the distance between these two houses, even if it's not a number. Okay, you could call it line segment AB. How about if we think in terms of the labels we've been using all week? We could use A, B, or C. But the point is, you need a letter. That's what I'm getting at. Some kind of letter. Be careful about the letters they already used in the problem. So they already used A, B's, and C's. So H or an X or a Y. Pick something that's different. Yeah. So let's call that side X. Now we need to set up the law of cosines using those three values and the X. So how would it start out on the left side of equal sign? Yep, X squared equals, and now follow the pattern. X squared equals 50 squared plus 70 squared
minus 2 times 50 plus 70.
2 times 50 times 70.
And then you're gonna cos. Would you put the 70 in there?
Yeah, you put the cosine of the angle that's across from the side you started. So that goes there. So one side squared equals the sum of the other two minus twice the other two times the cosine of the angle that's across from what you started with. Okay. And a lot of that we can do without a calculator to start. What's 50 squared? 2,500. What's 70 squared? 4,900. Okay, let's add those up. What's 2,500 and 4,900? 7,400. All right. What's 2 times 50? 100. And what's 100 times 70? 7,000. Cosine 70 degrees. And really, we can just leave all that. We don't even have to do that out. The only thing we do have to do is get rid of this exponent. So we don't want to know x squared. We want x, which is the distance between the houses. So what would we do with all of this stuff? Square root it. that's how you can pretty much do the entire problem without a calculator until you get to the last step. Now you need a calculator. Okay, and when you type it in, it's going to look exactly like you see right there. So square root 7,400 minus 7,000 cosine 70. Just type it in exactly the way we wrote it. And hit enter. Okay, so distance between the two houses is 70.752 feet. Questions on? That's how you find the distance between the two houses. And that finishes up everything that we're looking at for this week. So what we'll do tomorrow, we could take maybe up to 40 or 50 minutes to review the homework, and then if there's other questions people want to ask me, we do that. And then I'd say probably by like 2:15, maybe at the latest, 2:10, 2:15, we'll start the test, and then you'll be able to finish it on Friday. All right, so that's the homework for tonight, 274. And it's 9, 11, 13, 17, 25, and 27. And just a reminder, I will be after school today instead of tomorrow because of the open house.